coming to the session. I'll be presenting my job market paper, which is basically on coalition formation in public goods games. My paper uses both theory and experiments to see how we can use coalitions to make sure that that cooperation in the society is high, and how can we ensure that large-sized coalitions do exist. So in my paper, I try to see how we can ensure that when we have heterogeneous and private information, heterogeneity in terms of the individual's social preference, how can we ensure that large number of people agree to contribute to a public good? Examples can range from coalitions at a macro level, say international environment agreements, or people coming together, say, to contribute or provide for a park in their society. The related examples can extend to how people vote and why people pay taxes honestly. So there has been a background on why social preferences can be used to explain cooperation. There are various types of social preferences. For instance, reciprocity, equitable distribution, and Rawlsian preferences, which tell or explain why people actually contribute in a public goods game. And these heterogeneous social preferences are also able to explain the variation in individual contributions experienced in the society, as we know. And however, the question I'm trying to point here is how can we ensure that the large-sized coalitions exist, even in the presence of these heterogeneous social preferences? And how can we ensure that these large-sized coalitions will exist, even if the benefits from cooperation go high? Because there has been a theoretical prediction or theoretical results which suggest that when your benefits from cooperation go increase, there is a chance or an incentive for an individual to free ride, and the size of the coalition will reduce. However, that seems unintuitive, and that's what my model aims to look at it. How can we ensure the existence of these coalitions, even in presence of high MPCR or high benefits from cooperation? So I'll quickly go through the model before I go to the experiment part. So I assume that in a society, we have n individuals and all of them are endowed with one unit. And basically, I assume binary contribution to simplify the calculation. And I assume that either you contribute your whole endowment or you do not contribute at all. And the coalition size is assumed to be given by capital M. And I assume the fringe members are the people who do not join the coalition, but have to decide independently whether they will vote or not. So what happens if you join a coalition? So if once you join the coalition, the rule of the coalition becomes binding to every member in that particular group, and the coalition decides by majority. So for instance, if 5 of us in this session decide that we will join the coalition, and once we are in the coalition, the size of the coalition is 5, and 3 of us say that we want to contribute to the public good, but 2 of us do not want to contribute to the public good. So now the voting rule will come into action, and I assume the voting rule is using majority voting rule. So since 3 of us say yes, that we want to contribute, the coalition as a whole will contribute to the public good. So this is a two-stage public good game. In the first stage, when you enter the room or the lab, you decide whether you want to join a coalition. And in the next stage, we ask everyone in the coalition whether they want to contribute to the public good or not. And we also ask the fringe members whether they want to contribute or not. But the fringe members act independently, just like a usual public good game. I also assume that the social preferences are Rawlsian in nature, which basically means that individuals care for the least well-off person in their group. The preferences can also be extended to other types of cooperation, such as inequality aversion and caring for the social surplus, which I also test for in the theoretical model. So this is the basic setup. So when you are in the society of n individuals, you either decide to join the coalition. So you are, if you decide to join the coalition, then you are on the right side of the graph. You belong to capital M, and you have two options. You would either vote yes, you want to contribute, or you vote no, you don't want to contribute. And based on the majority, if the majority is satisfied, which is given by this greater than equal to M prime, then you contribute to the public good or not. And if you are a fringe member, you decide independently whether you contribute your endowment or not. So this is how the payoff is determined. Lambda I refers to the weight on your monetary payoff or pecuniary payoff, and 1 minus lambda I is the weight on non-monetary payoff. And I assume lambda I to be uniformly distributed. However, the results still hold true for other types of distribution. And gamma is the benefit from cooperation, which I was talking about, also represented as marginal per capita return or MPCR, which basically means that if I invest $1 into the public good and if I get $0.5 in return, then the MPCR of the public good is 0.5. And Q is the size of, Q is basically size of the coalition which is contributing plus the fringe members which are contributing. So Q can also be represented as the total number of contributors in a public good game, which also includes the fringe members who decide to contribute independently. So since there is a heterogeneity in private information, I use backward induction to first solve for the decision rule for the coalition members and fringe members, whether they will contribute or not. And I find that if the weight on the monetary payoff is below a certain threshold, which is given by lambda hat, then the coalition members will vote to contribute to the public good. And similarly, for the fringe members, I also find a threshold. So if your monetary payoff, weight on monetary payoff is below this threshold, then you decide not to contribute. Then you decide to contribute for the public good. And both these thresholds are increasing as we increase the MPCR or the benefit from cooperation. And I also find that the threshold for vote to contribution is increasing in size of the coalition. So if the size of the coalition increases, you are more likely to vote to contribute to the public good. And using the stage 2 results, I then derive the stage 1 outcome, which is the decision whether you want to join the coalition or not. And it basically says that if the weight on monetary payoff is below the MPCR, then I decide to join the coalition. And if there is an increase in MPCR or as gamma increases, more individuals tend to join the coalition. And obvious result from this proposition 2 is the fact that all the individuals who join the coalition also satisfy the cutoff for contributing to the public good. So in a way, the model is able to distinguish the individuals who in a society who will definitely join the coalition and henceforth contribute to the public good. So taking these results, I now explain my experimental design. The experiment in my dissertation is funded through NSF doctoral dissertation grant. The experiment basically is divided into 2 parts. In part 1, individuals play the public good game for 8 rounds. It's a plain public good game. This was done just to see how whether people can understand the public good game or not. After part 1 was completed, participants were given separate instructions for part 2, and then they played 12 rounds of the public good game. In part 2, individuals also had the option to join the coalition, and the payoffs incorporated the social preference, which is the payoff of the least well-off person. And in each of the 20 rounds, participants were grouped in a group of 6 different people. So after every round, you were put into a group of 6 different people, which may or may not have the same people from the previous round. So everyone was given 10 points with option to invest all 10 points into the private account or all 10 points into the group project. So instead of having the endowment as 1, I have there is the endowment of 10 because in order to help individuals calculate their expected payoff, we changed the endowment from 1 to 10. So participants earned 1 point for each point they put in the private account, and they did not earn any thing from the contribution of other individuals into their private account. On the other hand, when individual is contributing to the group project, they receive equal number of points from the total points in the group project. So if there are 4 people and 4 of them are contributing to the group project, then everyone in the group receives benefit out of it. This is the feature of a public good game. And earnings for each group member will be determined through a conversion rate, which is the MPCR in the game. And conversion rate was varied, was either 0.3 or 0.7, and it varied randomly over the periods. So this is the framework. We have the same framework from the theoretical model, but instead of endowment being 1 or 0, now the endowment is either 10 or 0. So the entire framework remains the same. Either when you join the coalition, you have to follow the majority voting rule on whether to decide to contribute or not. And if you are a fringe member, you decide independently. So based on the predictions from my theoretical model, I have the following predictions for the experimental result. So I had 3 values of lambda in order to cover the possible ranges of weight on the monetary payoff. So lambda I was 0.2, 0.5, and 0.8. A weight of 0.2 would mean that individual is not much concerned about his or her own monetary payoff, but is more concerned about the welfare of the least well-off person. Whereas a weight of lambda I of 0.8 would mean that individual is not much concerned about the payoff of the least well-off person, but is more concerned about his or her own payoff. And MPCR was 0.3 and 0.7. 0.3 would mean a low MPCR and 0.7 would mean a high MPCR. This is in line with the previous literature. So based on my prediction that if lambda I is below gamma, then you will join the coalition. The model predicts that individual who has a weight of 0.2, lambda I of 0.2 will always join the coalition. Individual with a weight as 0.5 will not join the coalition when MPCR is 0.3. And individual will weight 0.8 will never join the coalition. So here are the details of the session. There were 9 sessions. There were 3 sessions with heterogeneous payoffs, which mean that the computer randomly assigns the participants in the lab with either the weight 0.2, 0.5, and 0.8 in a manner that all the weights are equally represented in the lab. So we had 3 sessions of this type, and then we had 3 homogeneous sessions. Homogeneous session would mean that everyone in the lab had the same weight, either as 0.2, 0.5, and 0.8, but the individuals were not informed that, were only informed about their weight and not informed about the weight of the other individuals in their group or in the lab. So here are some descriptive statistics. The graph on the left suggests that individuals who join the is a time trend of individuals joining the coalition. And we find that when there is a high MPCR or high benefit from cooperation, individuals are likely to join the coalition. And similarly, in high MPCR, the graph on the right, the individuals are likely to contribute to the public good. These are again time trends about whether about the contribution to the public good. So since it's a decision, since you either contribute or not, so it's 0, 1. So the graph on the left suggests that individuals who join the contribute are very likely to contribute to the public good, with the probability being as close as 1 in some cases. So the prediction of the model, the results are in the prediction of the model, which suggests that whoever joins the coalition will also contribute to the public good. The graph on the right basically distinguishes the part 1 of the game, which was the pure public good game, with the part 2 of the game, which had coalition and social preference together, and plots the probability to contribute over the periods. So in part 1, we can see initially the probability to contribute to the public good is very high, but it falls over time. And this is consistent with the previous literature that in a public good games, the probability to contribute to a public good starts declining and reduces towards the end of the periods. However, in the second part, also we see that the probability to contribute to the public good is high in the start, but it falls over time. However, the fall or the decrease in the probability is not as sharp as in the part 1, which basically suggests that coalition, the presence of coalition and inclusion of social preferences might help us to explain how can we increase the contribution to public good games. And all these results are significantly different from each other, which mean that when I do a t-test in respect to how the probability of joining the coalition or contributing to the public good and the size of the coalition with respect to low MPCR and high MPCR, we find that the probability of joining the coalition and contributing to the public good are significantly higher when we have high MPCR. Basically signaling that, basically saying that high MPCR helps in ensuring a significantly high coalition size. Now I move to the regression results. So since joining the coalition is a binary variable, either yes or no, I use probit. And I find, so model 1, model 2, model 3, and model 4. So model 1 and model 3 are for both the sessions, which include the heterogeneous as well as the homogeneous session, whereas model 2 and model 4 are only for the homogeneous sessions. And as we can see, high MPCR leads to an increase in the probability of joining the coalition. And also, I included lag variables to see what impact the outcome of the last period have on this period's decision to join the coalition or not. And I find that if you have a higher payoff in the last period, then you are less likely to join the coalition. Whereas, as we can see in model 2 and model 4, if the payoff of the least well-off person was high in the last period, you are more likely to join the coalition, thus suggesting that there is presence of fraudulent preferences in the model. Also, so the reason why I distinguish model 1 sessions with all heterogeneous and homogeneous cases and only sessions with homogeneous is because I found that in the heterogeneous sessions, there was not much variation in the probability of joining based on the type you were assigned. So that's why I distinguish the sessions which only had homogeneous cases, because it might happen that once you are in the group, once you are in the lab, and when you see that others, when you see the outcome of other individuals, there might be a case that even though your preference would suggest you to contribute, but seeing the outcome, you might want to change the result. Similarly, we have similar results on the probability of contributing to the public good. Again, high MPCR leads to an increase in the probability to contribute to the public good. And again, the last period's payoff has a negative impact on this period's decision to contribute to the public good or not. And again, we see that payoff of least well-off person has a significant impact on decision to contribute. And as you can see, as these results suggest, when we have type 3, which is basically an individual who puts more weight on their own payoff as compared to the payoff of the least well-off person, model 2 and model 4 suggests that when we switch to these kind of individuals, there is a decrease in the probability of contributing to the public good. So individuals who do not have pro-social preferences are less likely to contribute to the public good. And last period's coalition size, so if the size of the coalition was higher in last period, that is also likely to increase the probability to contribute in the next period. In this regression, I test for whether the number of how the number of contributors behave based on the various independent variables. And I find that, again, that high MPCR leads to an increase in the number of contributors. And I also find that so in type 2, when you are at type 2, basically you care equally about the least well-off person and equally about your own payoff, then there is increase in the number of contributors. But whereas when you are type 3, which is lambda of 0.8, which means that you do not care much about the least payoff of least well-off person, there is a significant decrease in the number of contributors when they are of type 3. And similarly, the same thing, the payoff, your last period's payoff negatively impacts your output, and the payoff of and the size of the coalition positively impacts the number of contributors in the game. I have a similar, so this table is just done to see whether being in part 2, which is basically the game where we had both coalition and social preferences, does that lead to increase in the probability to contribute and the number of contributors? And I find that when you are in part 2, which is basically when we have coalition and social preference, that leads to an increase in the probability to contribute and the number of contributors as well, suggesting that coalition can act as a mechanism to sustain cooperation even when we have high MPCR, because inclusion of high MPCR also is able to satisfy these results. And
you have a minute left, so if you might want to start wrapping it up.
yeah, sure. I'll just have like 2 slides to go. So in order to control the impact, whether the impact is because of the coalition or the impact is because of the social preference, we also had control sessions where we tried to distinguish the um, rounds where the individuals played the game in a coalition from the rounds where individual played the game without the coalition and just the social preference. So this is the session details for the control sessions. And I'm not showing the results here because of lack of time, but I find that there are no order effects. So it doesn't matter whether the game of the coalition was played first or the game with social preference was played first. And we again, the probability of joining coalition and contributing is significantly dependent on high MPCR, and the contribution to the public good when only in those games where we just have social preference again significantly depends on the payoff of least well-off person in the last period. So in summary, incorporating social preferences in public good games can help explain the existence of large size coalitions. And again, the individuals who have a lower weight on pecuniary payoff or individuals with pro-social preferences are likely to join coalition and also contribute to the public good. And even if this mechanism is able to tell us that even if we increase the MPCR or the benefit from cooperation, we are able to sustain the size of the coalition and increase cooperation in the society. And again, the joining and contributing to the public good also depend on the payoff of the least well-off person. Thank you. And if you have any questions, you can email me or yeah, I'll stop sharing now.